Hello everyone, so in this video we will look at the lead code problem 1759, that is count number of homogeneous substrings. So the problem statement states that we are given a string S and we have to return a number of homogeneous substrings of S. And since the answer can be large, we have to return with the modulo 189 plus 7. So homogeneous strings are if all the characters of the strings are same. So here, if example we are given A double B C C C A. So a homogeneous string is a single string is always homogeneous. Like BB here is a homogeneous string. BBC is not a homogeneous string. It's not that BBC. It's just normal BBC. So BBC is not homogeneous because now we have different characters C here, but normally BB is. Now CCC is homogeneous, but CCCA, if we consider this, it is not homogeneous. I hope so you got it. So this is what we have to do, and we have to return the number of homogeneous substrings for that particular string. So substrings, I think everybody knows, like if I have A B B C C C A, any continuous part of it will be a substring of this complete string, right? So how we can do this? So there were a couple of approaches. So in the brute force approach, we can use two for loops, or a for loop or a recursion, and we can, like, check for all of these. Like for A, I will check, okay, till A I have, sorry, A B B C C C A. I will check for A, okay, it is homogeneous till this point. I will add 1 to my count. Then I will start from B. It is homogeneous from till this point, so it will give me +1. This B will also give me +1, and this will completely will give me a +1, right? Then I'll start from here. Okay, it's a single C, it will give me +1. Another one with it will give me a +1. Another one with it will give me a +1. Then I will start from here. Okay, so this one will not be here. Okay, then I'll start from here. Okay, this C alone will give me +1. This C will together with this one will give me +1. Then I start from here. This single one give me +1, and this way we can do that. That was the brute force. Now let us just go to the optimized one. So if you observe it properly, you will notice something. There are two ways in which I did it. I'll discuss both the ways. So way one, we will discuss way one first, and way one will have a time complexity of I would say O of n, where n is the number of strings, right? And space complexity of O of 10 to the power 5, which is the constraint here, right? The maximum length of the string. So O of n only. But okay, so first approach has the time and space complexity like this. So what was the first approach? So for example, if I have a single A, what is the number of homogeneous substring here? 1, right? Just bear it with it. Now I have two ways. What is the number of homogeneous substrings? A, 1, okay, another A, 2. Now these two together, 3. So it is 3, right? It is 3. Let's just write it. Now I have A. Now let us again look. Single A, 1, single A, 1, single A, 1. It is 3. Now these two will make it 4. These two will make it 5, and these 3 together will make it 6. So this time it is 6. Now for 4 A's, A. You can do this or like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Then we have done something wrong. Okay, let's just count that again. 1, 2, 3, 4, right? 5, 6, 7, 8, 8, 9 and 10, right? For 4 it is 10. Now do you observe something? There is some pattern. Okay, let's say the length, I will write here the length of all this. Length 1, 2, 3, 4. These are the length. Do you observe something? The first one is 1. The second one is, I can write it as 2 plus 1. This one I can write as 3 plus 3. This one I can write as 4 plus 6. Are you observing something here? Like, for 2, I am adding the length of that particular substring. For A, it's 2. I am adding 2 with the answer of previous one, 1. For 3 I am adding the length that is 3 with the answer of previous one. For 4 I am adding the length 4 and 6 here with the answer previous. Are you getting like what we are doing, right? So this is one pattern, and we can like you can code it. I know if you get it, like what you can do is you can create a vector of 0 to 10 to the power 5, right? 10 to the power 5 vector, and it will be 0 at one position, it will be 1 at two position, it will be 3 at third position. Then from third position you can calculate it. So you can run a for loop for I is equal to 3, I less than equals to n, I plus plus, and your vector of I will be equal to I plus vector of I minus 1. This way you can store all this, and then all you have to do is find the length, right? How many of these are together, the same value are together, and that way we can do it. And how we are going to do that, that is also simple. All you have to do is keep a length variable. Initially it will be 1 because a single character is always homogeneous, and then you can also keep track of previous one, that, and previous will be previous will be s of I, because, and we will start our loop from a b b c c c a, and we will start our loop from here, and we'll check, okay, previous is a, and it is not similar, right? So I'll add to my count vector of 1, which is here 1. So I'll add 1 to my count. Then I go here and previous is b now. Then I go here, okay, previous is b, okay, so these are same. I'll do a length plus plus, so length will become 2. Next time I come here at c, it is not same. Oh, it is not same, so previous will become c, this value, right? Length will become again 1, and the length was before 2, so count of 2. We'll add 3 to it, it will become 4, and this way we can do it. You can get it when we'll code it, you will get it, and you can dry run on your own, and it will be super easy. Now the second approach, okay, we will again see it. So for a I have 1, for a I can 1 plus 2, I had 3, right? For a I had 6, 1 plus 2 plus 3. For I had 1 plus 2 plus 3 plus 4. Now I am writing it on my own, which is 10. For I will have 1 plus 2 plus 3 plus 4 plus 5. You can write it on your own, and you can see this pattern. In both the cases, there will be a pattern. Now if I write it 6 times, it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? This way you can do it. And in this case the time complexity will be O of n for traversing my whole string, and the space complexity will be O of 1, because this calculation can be done right, with n into n plus 1 divided by 2. Since the answer will be very high, we have to do modulo here, so we can take care of that, and this way we can do it. And the counting the length will be done in the same way in both the approaches. Right now we will just move directly to lead code and code it, and you can just get the idea how we can do it. First of all, I'll recommend you to try the code on your own for 5 to 10 minutes, right? You can also give more times as per, but not more than 15 to 20 minutes if you are watching this video. And I do encourage you to solve this question on your own first, and like for half an hour minimum at least, and then you can go to the editorial tutorial YouTube videos or anything like that. Okay, so now let us just go to the lead code and solve. Okay, so here I am in the lead code ID, and we will start with the optimized approach 1 and optimized approach 2. So first of all, I'll do the approach. So what we were doing first of all, and there is also one edge case which I did not tell. So for example, if the length of the string is only 1, then we have to return 1 only. So let us just do that. Int n is equal to s dot size. We'll get the size of the string, and then what will we be doing? We will just check if my n equals to 1. I'll just return 1, and after that we were doing declaring a vector of int vec. It will be of size what are the constraints, 10 to the power 5, so it will be 1e5 plus 1, right? And now I'll vector of 0 will be equal to 0, vector of 1 will be equal to 1, and vec of 2 will be equal to 3. Now I'll run my loop for int of I is equal to 3, I less than equals to 1, less than equal to 1 e9. I can move that. Less than equal to 1 e5 and I plus plus, and after that vec of I is equal to I plus vec of I minus 1. And then we were finding the length, so int length equals to 1 and int count equals to 0. Now I'll start for int of I is equal to 1, I less than n and I plus plus. So if my, okay, I also need a previous, so character previous is equal to s of 0. So if my previous equals to s of I, I'll increase the length simply, length plus plus. Else if it is not, then what I'm going to do, if it is not, what I'm going to do, my count will be equal to, it will be equal to count mod of I'll add the value val plus vec of length, length length value, right, mod value. So let me just declare it over here. So int value equals to 1 e9 plus 7. And after that, what we were doing, we were setting previous is equal to s of I and length equals to 1, and in the end I will be returning the count. So if we submit it, it should run until and unless we have made some mistake. Okay, length plus plus. Okay, now let us just submit it. Okay, there is a overflow at some point. Okay, so we had done some error here. I'll just take it till n only, that is why we are getting the error. And because we are taking it till n, because the size of a string is if 6, then we need value till 6. The maximum repetition will be of 6. We don't have to calculate it till 1 e5. So that was my mistake from my end, right? And it will be equal to n, and the size will be of n plus 1 obviously. And now it should work. Yep, I believe it should work now. Now let me just submit it. Okay, it is giving wrong answer. Let me just look where I have done the mistake. Yeah, okay, so the error was, right, the error is after we have terminated, if I have two characters at the end, if I say I have a b b c c c a a. Okay, so I traversed and I did not find, I am out of this string, I am out of this loop, and my length is 2, and this condition never met, so this thing never happened. So I have to add that at the end. That is why we were getting that error. So I'll just add int answer equals to count mod value, then I'll do a plus vector of length, then mod value again, and after that mod value again, and I'll, instead of count, I'll return answer. I could have done count plus, but it's fine. Now if I submit it, it should be submitted this time. Okay, so these were small mistakes I did. Now let us just go to the second, what we say, the second approach. So everything will be same here. I'll keep the value, I'll keep these conditions, I'll just remove this array, I don't need it anymore, and everything else will be same here, and we just need to update the how we are calculating this over here. So that is something we will update with that formula. So everything will be same, and here length plus plus, and we will take remove this here, and we'll take okay, a variable int gg. We take a variable int gg, and I'll call a function with my length passed as well as the value we have defined 1e9 plus 7, right? And then I'm going to count equals to uh, count mod value plus gg mod value That is what I'm doing, and in the end this one will be here only, but we don't have a vector here. So instead of this vector, what we will be doing, we will call my function on the length as well as the value will be passed, right? And now I need to write this function. So what this function will do, this function will be integer. It will return integer function, and it will take length as well as it will take value. And here I'll have a long solution which will be equal to uh, long, which will be equal to long length mod of value into long length plus 1 mod value. And here my I'll return int of solution divided by 2. Now if I submit it, it should be submitted as well, and the space complexity will be little less for this one. Okay, we have in line 5 we have some error. Okay, so this one is closing over here, this one is for this, and we don't have one for this one. And okay, I don't need one here actually, right? Now let me just submit it. So as you can see, this one is also submitted, this approach. So I hope so you did understand how to do it, and make sure to you know try run it on your own to get a better understanding of this approach, not this approach but all the both of the approaches. And do like and subscribe to the channel, and I hope to see you all in the next one. Till then, stay tuned.